Hello, Intro to Algebra students. We are looking at page 269, and we're going to go through example 3, continuing in chapter 4, lesson 1. And we're looking at example 3, where we have the total distance that Marion ran in 1 week shown in the graph. And the first thing we want to do for number 3 is to write an equation to find the number of miles ran X after any number of ran y after any number of days x. So we're going to write an equation. We need to make sure, if we're looking at equations, we know we write equations for linear graphs. And so we want to look at this graph and see, is there a constant rate of change? And hopefully you can spot that the rise over run is the same, or you can find the slope and that is the same, or you could do y divided by x, y divided by x, y divided by x, and that is the same for each. And so it is a linear graph and it does have a constant rate of change. Then to write an equation, we need to make sure we're finding the slope. So you can see that they're taking, to find that rate of change, they're finding the slope, and they've chosen 2 points. And they subtract the y minus y for 14 minus 7 over the x minus x, or 4 minus 2. And they're getting a slope of 7/2, or 3.5. Now, this one is not proportional. If you look at the graph, as the line comes down, it crosses near 0, but not at 0. And so we have a y-intercept. Now, to find the y-intercept, you use the beginning of the equation that you found by plugging in the slope. And then you're going to take a point, and you can choose any point. They have chosen the point 2, 7, and you're plugging in the 2 for x and the 7 in for y. And then they solve that equation for b. Now, they're not showing the work for solving that equation, so let's just put that over here. So we have here 7 equals 3.5 times 2 plus b. And again, that 2 and 7 are just coming from the ordered pair on the graph. You can pick any ordered pair and plug it in. And then solving. So we can do this multiplication, and that gives us 7 plus b. And then to get b by itself, we're subtracting 7. And we get that b is equal to 0. And that's how they're concluding that the y-intercept is. Hello, Intro to Algebra students. We're taking a look at page 269, example 3 today. And number 3 asks us to write an equation to find the number of miles ran y after the number of days x. And one of the things we want to look at when we're looking at a graph is there a constant rate of change? So you're deciding whether or not that rate of change is constant. And to decide whether or not the rate of change is constant, you should be taking y divided by x and seeing if that's the same for each example. So the rate of change is constant, and we know that the rate of change is the same thing as slope. So another route when we're looking at writing an equation is to find that rate of change using the slope formula. And they've chosen to do y minus y, 14 minus 7, over x minus x, 4 minus 2, and of course resulting in a rate of 7 over 2, or a slope of 3.5. Now, one of the things we have not looked at yet in this chapter is making sure it's proportional by checking for a b value. To find the y-intercept, we use that beginning equation that we came up with the slope plugged in for m as 3.5. And then you can choose any point. Now they've chosen the point 2, 7, and they're plugging in the 2 for x and the 7 in for y. And then you solve for b. Now they're not showing their work for solving for b, but I'd like for us to show that. So we take our equation, y is equal to 3.5x with the slope plugged in, and then we are plugging in an ordered pair. And again, they chose the ordered pair 2, 7. And so we'll use that same ordered pair. But we're going to do that multiplying so that we can solve for b. And 3.5 times 2 is 7. And then to get the b by itself, we're subtracting 7 from both sides. And that's how they ended up with the b equal to 0. So the slope is 3.5 and the y-intercept is 0. And so the equation of the line is y is equal to 3.5x plus 0, or just 3.5x. Now that y-intercept of 0 does tell you that the graph is proportional. So looking at example 4, we're looking at using the equation that we just came up with, the y equals 3.5x, and we're answering a question to go with it. So we're asking, how many miles will Marion run after 2 weeks? And in order to do that, we need to decide, since our y is the number of miles and x is the number of days, we need to first decide how many days is 2 weeks. Hopefully realizing that 2 weeks is 14 days, and so plugging in that 14 for x, and that's how they're calculating that Marion will run 49 miles in 2 weeks. So just making sure that your units of measure are the same, and then applying your equation. So turning to page 270, and we're looking at that got it for part C and D. And we're writing an equation to find the total number of trees y that can be saved for any number of tons of paper x. So that is reminding you that we want our y to be the trees, to represent the trees, and the x is representing the tons of paper. So anytime you're asked to write an equation, most of the time we're asked to write an equation, especially when we're looking at a graph, I want you to be thinking about y equals mx plus b, and thinking through that. Now you can take a look at this graph, and it is linear and proportional. So that proportional piece tells you that the b value is going to be 0. So as you're writing your equation, you're really thinking about writing y equals mx. So I'd like you to take a moment and find the equation, which means you are finding that m value to plug in. So hopefully to find that m value, use the slope formula, and you're going to pick 2 points and just plug that into the slope formula. Now I chose the first 2 points, so I'm doing y minus y, 34 minus 17, over x minus x, which is 2 minus 1. And that gives me a slope of 17 over 1, or 17. So you should plug that in and hopefully get your equation of y is equal to 17x. Now then you're going to use that equation for part D and use the equation to find out how many trees could be saved if 500 tons of paper are recycled. So you need to plug that 500 tons of paper into the equation to find that value. So hopefully realizing that your tons of paper is your x value and plugging that in, and you're able to get that y is equal to 8,500 trees. So looking at the key concept box here, just as a reminder, this is always a good resource for you, that we're representing relationships with in multiple ways, that we can represent relationships in words, and that same relationship can be shown with an equation, a table, and a graph. So they are all related to each other. Remember that you can rewatch any part of the video that you need to. Have a good day.